Well, I've got a new toy. I think it's actually bent my trailer. This thing right now is under this tarp, or vinyl sign thing that I bought as a tarp. But this is a Mitsubishi CO2 laser, or it was. About fell. But this came from work. My boss bought it, was going to use it, decided not to use it, and told me to scrap it. So I scrapped it to my house. This thing, if you look at the steel, how thick this is, I don't believe it's a casting, it's welded to it. But, I mean, the thickness of this stuff, it's heavy. It's somewhere around, I'm going to guess, 12 to 15,000 pounds. But I'm probably going to end up taking a lot of this stuff off of here. There's a lot of things that I'm not going to use, but my intention, it's either a 6x12 or a 5x10 table. I can't remember which. But you've got linear ways, you've got stepper motors in here, bunch of good equipment that would be a waste to just send to the scrap yard. So my intention is to turn this into a CNC plasma table, and possibly a CNC router, so you could convert it between the two. If you look at the way it's built very rigid, very solid. They were made for high speeds, so they had to be built very rigidly in order to handle the speeds. So a slow router, I think, would still be okay. It's already got the gantry, it's already got all the ball screws and everything that you need. So I may not be able to reuse the servo motors. I may have to put something else in there, but I can adapt it pretty easily. Now the question is, where the heck am I going to put this thing? I've already pretty much used this pad for what I'm eventually going to do when I put everything together. He also got rid of some pallet racking, so I've got it stacked here all over the place. I really need to mow. It has rained and rained and rained and rained some more. So I've got a mess. And I've got this truck in my garage that's sort of stuck here. But yeah, it's actually, I don't know if I'm going to put it in here, because that would pretty much take up the entire pad. I've actually thought about bringing it out here and putting it right here in this area, right through here. I don't even know that I'll pour concrete. I may pour footers for it to set on so I can level it, but I don't know that I actually need concrete for it to do what I want to do. Or I even thought about pouring it back here, putting it back in this area, because I really don't want to take up all that room if I can help it on my concrete. That stuff's expensive and precious. So I want to use that to work with, not have a piece of equipment sitting on it taking up basically the entire pad. But yeah, that's a new piece of equipment, and I guess I'll document converting it and how I do that and all that good stuff. So let's see, show you what I've been playing with here. I've also got this that I traded for this lift over here. This is a little scissor car lift. Got it from a buddy of mine. Somebody had put way too much weight on this thing at some point and bent the scissors just a little bit. I don't know that I would put anything like a car on it that was like that thing. I would never put that truck on it because it's too heavy. But I think it's like a 6,000 or 7,000 pound lift. But I've actually considered making like a table that insets into concrete somewhere with it. So when I pour my concrete, kind of pour around it, have this inset into the concrete somehow, to where it's flush, and then put a big piece of steel plate on top where I could literally just hit a button and pick something up that I'm working on, that weighs, you know, however many pounds. So if it'll pick up a 7,000 pound vehicle, then I would imagine it would pick up a lot more than that. Well, a lot more than most of the stuff that I work on that's 1,000 pounds or so. So anyway, but this is one thing I've been working on. So these are stepper motors that I bought. Stepper motor drivers. I forget what you call these things. Breadboard. This is a little control for like 35 bucks that you can buy on eBay. And I've just been playing with it. I bought another one. I've got this one here. And let's see, I've got another one somewhere. This one, the Ethernet, a little relay board, some different sensors, power supplies. So I think this is a 24 volt, and those are 24, 36, and 60 volt power supplies, and stepper motors. So I've got some bigger ones, some drivers. Those are the bigger stepper motor drivers for, I think, these stepper motors. These are for closed loop stepper drivers. These are for open loop. And here's another one of those boards. This is a little thing that a buddy of mine gave me. He works at an electronics recycling place and gets a bunch of little goodies like this on a regular basis. But I've installed Mach 3 on this little thing and run all of my pins out to here just to kind of test, hook stuff up and play with it, see how it works. But if you look at it, let me reset it and go use the arrow keys, so you can see these running back and forth. This one running back and forth, and that one. So there's your X, Y, and Z. And I actually just playing with it because I wanted a way to do two motors on one drive. If you notice, I've only got 3 axes. So I've got X, Y, and Z. And I've got 4 drivers. And essentially what these things do, it's actually kind of cool, is you've got 4 wires coming from the stepper motor here. And if you put 2 of these wires together, I got the wrong one. Yeah, I can't do this with one hand. But basically, you can turn this thing by hand pretty easily. But if you were to take 2 pair, and I think green and black are 2 pair, and I'm trying to hold them together like that, now I can barely turn that shaft. And if I were to put the other 2 together, there's no way I could turn that shaft by hand. But that will tell you which 2 pair are your coils. So there's a coil and there's a coil. The red and blue and the green and black. So you run those wires into here. So your B and A. So your one coil goes here, one coil goes here. your voltage, and I'm just using this power supply for now. I've got 24 volts coming into the volts and ground here, and I've got 24 volts going into this part of my breadboard and then into here. So there's my 24 volts. So there's those. That goes directly to my stepper motor over here, wherever it's at. And then you've got this right here. Let me see if I can zoom. So you've got direction minus direction plus, pulse minus pulse plus. So I hooked it up to this thing just to see how it worked. And basically, let me grab this other board so you can see it a little better. What I've got is you've got 5 volts here, and then you've got an XP and an XD. Oops. And so what you do, you run your 5 volts to this positive and that positive here and here. And then your XP goes in the pulse negative, and your XD goes in the direction negative. And what it does is it will pulse, X number of pulses to get this motor to turn. So however many pulses you tell it to turn an exact amount. So then if you want to change directions, it will apply 5 volts to this. It grounds this direction out. It doesn't actually apply 5 volts to it, but you get 5 volts to, or you get the negative, I guess, the ground to the positive, which tells this thing to change the direction. So it's literally 5 volt signals that go to it. I don't really know what this does yet. And if you look at some of these other ones, so these are a little more fancy. These were cheap. These were like $10 a piece off of eBay. The open loop motors are not terribly expensive. They're fairly affordable. The closed loop, and here's a closed loop stepper. See, you don't just have your 4 coils, and this one's a little fancier too. It comes with a little connector. But your 2 coils. You've got 4 coil wires. You also have this connector, a little, looks like a video VGA cable or something. And so with this one, you got your same pulse, direction. Still don't know exactly what those are. And there's an alarm where if something happens to your motor, this will actually tell your control that something is wrong. Somebody's trying to call me. There. And then you have an encoder. And then you have your voltage to your voltage in and your voltage to your motors. So what's cool about these versus these versus these is with this driver and this open loop motor, I can't do it right now, but I could move this. I could actually overpower it. It's actually applying amperage to this thing, holding it in position. So I'm having a hard time turning that. Well, I just got it turned a little bit. Oh no, actually it just slipped on the shaft. But regardless, if I had a big lever out here, I could just overpower that motor and turn it, 2 or 3 degrees or whatever. Nothing would feed back to the system. My control would have no idea that this motor was turned, and it would continue to operate. So if something were to happen, or maybe it gouged into something and something quit, this motor would have no idea that happened. So that's a problem. And then it's also applying that amperage to all 4 of these motors on a regular basis. So that 1 amp is going to all of these motors, just trying to hold them in place. No, shoot. Where eventually you're going to generate heat doing that. I bought these little NEMA 17s to play with to begin with, and they work, but they get really, really hot. Like, I mean, you can almost not touch them, they get so hot. I don't know why those are getting so hot, but these are not. So these will just sit here and idle, and I mean, it may be that it's more driver than the motor really wants. I don't know. I think you can get smaller drivers for these, and I may look for some of those. But honestly, I want to go bigger more than anything. So I've got a lathe that I'm going to be probably converting using these steppers. So give you an idea of cost. I don't remember what these cost, but they were, I don't know, 30, 40 bucks a piece, something like that. These were 2 or 3 times that cost. These 3 here with these 3 encoders and those 3 power supplies, it was almost 700 bucks for those. So I don't know how much money I've got sitting here, but it's more than I really want to admit. But either way, the beauty of the closed loop is, you notice where'd my little driver go? Here it is. So on a closed loop, I've got micro steps. So in other words, when I change these switches around, I can have 200 pulses per revolution, 400, 800, 1,000. That's 1,600. So, you know, you can have more resolution by changing this. Same thing here. Yeah, come on. Let me see if I can zoom. There we go. So you've got different pulses per revolution. But if you notice, this only has 1 chart, and that one has 2. So this one has your pulses per revolution, but it's also got how much current do you want to feed this thing. I think right now I'm setting them all at 2 amps just because I'm not exactly doing anything ridiculous with them. This one does not have current because it supplies current as needed, because it has an encoder feedback through that port there. It knows if this is being turned or somebody's trying to turn it or whatever. If you're applying voltage to this, and I actually haven't hooked up any of these yet, but if you're applying, let me rephrase, you're not actually applying amperage necessarily to these to get them to hold. What you're doing is it's kind of sitting there resting, and if force were to be put on it, it will start applying amperage. So where these will get hot, these don't get hot as easily because you're not applying amperage to them all the time. It only applies amperage when needed, and it only applies as much amperage as needed to do the job. So they run cooler, and they will also return. So they know where they're supposed to go. They know that, you know, I'm supposed to be at 12 o'clock, but something just moved me over here, and it'll snap back to 12. So they are more expensive, but where I'm probably going to use these for maybe my plasma table. Not that big one out there. I'll probably use something more like this for that plasma table. I'll probably get some more of these to do that one if I need to replace the servos that are on it. Hopefully I won't have to. I can just use what's there. But who knows? We'll see, I guess. But my press brake is probably going to use a combination of these and these. So what I was going to do is my Z, which is really my critical, when I say my Z, my in and out. So the fingers will be back here. You push your metal up against them to give you a back gauge to bend something with. Those need to be perfect. And so I'm going to use these so it keeps track of everything and knows where it's supposed to go and all that kind of stuff. So I'm going to have 2 controls for that, or two of these for that, which I've already got. Ooh. And Let me put this back. And for the other ones, which is the fingers this way, that honestly can be relative. In other words, if it's a couple thousandths off or 10 thousandths or 50 thousandths off this way or this way, I can just adjust it. It's not the end of the world. It really don't matter. So I'm going to use the cheaper drivers for that. And then the up and down, again, same thing. Not the end of the world if it's not exactly perfect. But the in and out, where I'm actually going to be gauging against, that needs to be right. So I'm actually going to use these steppers for that. And I'm going to have these two for that one drive, just like you've got these two paired together. There we go. So you can see that they both move. And then that one moves by itself. And then that one moves by itself. It's supposed to. There we go. So anyway, but yeah, that gives you an idea of some of the stuff I'm doing. But what really struck me about this isn't that hard to do, and it's not. Well, it's expensive, but it's not as expensive as you would think. The components aren't that bad. And I mean, I've got a machine shop, so I can make all the little brackets and all that kind of stuff if I need to. So I've already got CNC stuff to make more CNC stuff with if I need to. So right now, I was up till 2 something this morning designing enclosures for this stuff to mount into. And, you know, if you wanted a plasma table, really, a little card like this, I don't see why that wouldn't do the job. The only thing that would worry me is maybe some noise coming from the plasma cutter screwing with the board. There's a couple of boards that I found that say they have a very strong anti-static whatever, so they handle that a little bit better. But I'll probably order a few more of those. As you can tell, I have a tendency to go overboard and order more than I need because I like to play with it. So I told my boss he's going to have to give me a research budget because this stuff always ends up benefiting him as much as it does me. We're already looking at automating some stuff at work using, you know, this kind of stuff. So, but yeah, I mean, you can buy these little power supplies here. They're not that expensive. You can buy a lot of these components. Again, this stuff really isn't overly expensive. It's just knowing how to hook it up, I guess. And these little things are handy for a lot of this stuff because you can, you know, play with different hookups and it's all temporary. So this gave me a way to sort of mess around with it and see what all you could do with it without a lot of hassle. So anyway, but yeah, that's what I'm looking at right now. So hopefully I'll have a much bigger plasma table and a CNC router that I can use to do a bunch of neat stuff with in the next few months. And I'm probably going to add an A-axis. So again, if you look at this card, and this one was just kind of a cheap one that I wanted to play with, you have, let me turn this light on too. There we go. You've got X, Y, Z, and A. So you've got 4 axes on this one. On this one, it's I think 6 axes. Yeah, so all the way up to, oh, that's your spindle. 1, 2, 3, 4, 5, 6. Yeah, 6 axes. And then I believe this one is also a 6 axis. So this one has more axes on it. And it also has more inputs and outputs. So if you notice, I've got this whole bottom row is inputs and outputs on this one, where this one just has, you know, like 4 here and 4 here. So it really don't have just a whole bunch of inputs and outputs on it. But again, if you're just building a simple plasma table or engraver or something fairly simple, why not? It would work great for $35. It's just something to play with. It's and also for just controls, you know, There's a lot of stuff that we have to do where you just move this way and move this way and clamp this over here and do this over there and maybe use an air piston to do something here. I was even thinking about, like a bandsaw, automating a bandsaw. You could use this card and have your inputs and outputs set up to where you could, turn on not hydraulic. Well, you could do hydraulic, but like an air cylinder valve. They're $15 for a valve, and you could control it with this little board. And you could have an air cylinder that clamps your workpiece. You could have a servo that pushes it forward, unclamp, pull back, and then clamp, and then saw, and then move forward again, unclamp, pull back, clamp, saw. So you could literally have a precision way to saw material if you wanted to, where you could even automate that process. Where I want 200 of these, you could literally write G-code to where it will pull this, do this, all that kind of stuff. So little simple tasks like that you're paying an employee to do, or that you just are doing yourself. If you got to cut 30 of this bar, that little $35 card and some motors and a little $12 doodad right there will get you really close, probably closer than you could do it yourself. So anyway, just something I wanted to run by people and see what you thought. So you guys have a great day.